Hello everyone. So the problem is solve the given differential equation by separation of variables. Dy over dx is equal to cosine 12x. So whenever we are dealing with separation of variables, our goal in this problem is to have dy by itself. So step one, isolate dy by itself. So we rewrite the problem, dy over dx is equal to cosine 12x. So to isolate dy by itself, we simply can multiply dx to both sides. So this was going to simply cancel out the dx. So it's going to be dy is equal to cosine 12x dx. So we're done with step one already. Now simply for step two, when we're dealing with separation of variables, is take the integral to both sides of the equation. So we say, okay, so we write the integral of dy is equal to the integral of cosine 12x dx. We're just simply copying everything right here, and we're just finding the antiderivative on both sides. So what's the integral of dy? It's simply going to be y. We rewrite integral of cosine 12x dx. Now, when we're dealing with integral of cosine 12x or sine 8x or stuff like that, the best method to solve this integration is by using u. I'm going to write for short, but it's known as u substitution. So we write u is equal. So when it's easy to find the integral of cosine, but what's making hard for us is this right here. Our 12x dx. It's together, so that's what's making it difficult to find this integral. So this is going to be our u. So our u is put the difficult number into our u. So it's going to be u is equal to 12x dx. So when you're dealing with u substitution, you have to take the derivative, not the antiderivative. Could be a little confusing. So it's going to be du is equal to, what's the derivative of 12x? It's simply just 12 dx. So we know that, let me see, we know that dx is going to be du over 12. That's our solution. That's our answer to our u substitution right here. So we copy this problem again, the equation. Y is equal to the integral of cosine. What's our 12x now? It's going to be our u. And what's our dx right here? It's going to be equal to dx equal to du over 12. Great. So what we could do after this is we grab this 12. We could take it all the way in front of the integral. It's going to be y equal to 1 over 12. The integral of cosine u du. And so we know that I always write it out. Derivative of cosine dx is equal to negative sine x dx. The integral of cosine x is equal to sine x plus c. Always remember the plus c. So we say, okay, y is equal to 1 over 12. What's the integral of cosine? We have it here, sine but we're not dealing with x yet. So we're dealing with u. So sine of u plus c. And then remember, guys, always add the plus c, because most students, including myself, when I was first introduced, I was always leaving it without the plus c, but that's incorrect. Most teachers and professors could mark up points, so remember plus c always when you're dealing with antiderivative. So now we have our u right here, and we go all the way up. When we dealt with u substitution, our u is equal to 12x, and we're going to plug it back in. So y is equal to 1 over 12 sine of 12x plus c. So this is the final solution to this problem.